The topic is data structure. We are going to start subject that is data structure. The first thing is, when I am discussing or explaining, you should not write anything. And I'll give you time for copying everything from the board. And also I will repeat the points. I will not dictate word by word. I will repeat the points so that you can prepare your own notes. All right. So let us start with the introduction to data structure. What are data structure? Why we need data structure? Right? We will discuss about this thing first. Now, instead of directly going into GATE, little bit overview I'll give you so that you understand what is the importance of data structure, because there is a question with the students that is it really useful now because of AI, no programming left. Nowadays, there are many questions. So shall we study data structure or not? And when you're learning data structure, at what level you can study? There is also a question, what you should study from that in data structures. So I'll give answers to these type of things. Then I will show you what is the GATE syllabus. Then we'll start the topics. Okay. See, let us start in this way. We have been learning that we write our programs and we keep them on the hard disk or stable storage. I'll start from here. All right. So it's like a story. Just you have to listen. So this is my program. Whatever the language I have used, I have written the program. Now program, when I want to execute the program, this should be brought into random access memory or main memory. You know how the program gets loaded and it will execute. So it's executed by the CPU. So program is loaded and it's executed by the CPU. You know well this. Now the question is, program is nothing but set of instructions. So those instructions are performing operations on what? They are performing operations on data. Without data, there is no use of program. So data is mandatory. So now the question is, next thing is, from where this program is getting the data? From where it is getting? So is it inside the program itself? If it is inside the program, means constant values. So everything is constant, means nothing big it has to do. So program may be getting the data from somewhere. So what are the sources from where this program may get the data so that it perform operations on it? So it may get the data from the input device. You may be entering the data like input this value, input that value, scanf or C in, you will read the values. All right? In different languages. So it may be getting the data from the keyboard input. But you will not get many bulk size data from here. You may be entering few values from this one. Now what are the other sources? Now data may be already there on the storage in the hard disk in the form of file. Like this is my data. This is my data. And this program is using this data that is in the file. Second source. Source 1, source 2. Two places. Or program may be getting the data from some other computer or remote machine, remote computer or remote machine via internet. It may be getting it via internet. Like you access internet nowadays, you pull a lot of data from internet. All right. From the keyboard, you may be entering limited values. From file, you may get large size data. Now when it's coming from internet, you may be getting huge amount of data that program may be receiving. Like you are loading a web page. Web page is brought into the program and program is using that page, showing that page. So, all right. Now, where the data should be so that this program or can perform the operations upon the data. Where it should be? It should be inside RAM. Data should be inside RAM. Then only program can perform operations on it. All right. By keeping it directly on the hard disk from the file only, it cannot perform the operation. Internet on the remote machine only, it will not perform the operation. It should get the data, then whatever it has to do processing, it can do only if it is there inside the main memory where the program is running. Right? So when that data is coming here, how you organize the data so that the program can use it efficiently. How? Where it will be stored. You will not be getting 1 or 2 values, 10, 5, 8, like this. You will not be getting simple values or scalar values. You may be getting bulk size data. Now the question is where that data will be organized. How that data will be organized inside RAM so that program can perform the operations on it. All right. So like you know that this is the stack. Okay. This is the stack. This is stack. And this is heap. And this is code section. All right. So data should be present either in stack or heap. Now you're getting the, suppose, HTML page, you know, pages are made in HTML only. HTML is a collection of data along with the tags. Data along with the tags. So all that thing is kept inside a big size array, or it may be kept in the form of a linked list. How it is organized, don't know, but the program will be using it by keeping it here. All right. Now, once again, program cannot process upon the data which is outside its context. It has to brought within its context or inside the main memory, I should say. It should be brought inside the main memory so that it either it is in the stack or it is in the heap so the program can access it. Now the question is how you organize the data, large size data in this main memory. Organizing, structuring. That's it. It's nothing but organizing data. So what do you call to organizing data so that program can efficiently utilize it? What do you call to it? It's nothing but data structure. Nothing but data structure. Data structure is nothing but organizing data so that program can efficiently utilize the data. But where the data should be? That is the important thing. Not on the hard disk, not on the storage, on the data. Sorry, inside the main memory. Then only we call it as data structure. Now the question is why it is called as a structure. They should have called it as data organizing. Why they call it as a structure? So this is my analysis, or what I believe is what. See, program is running over the data. So who is giving the foundation to the program? Data only, right? So like if you go to other engineering, first you will have some structure over that the product is built. Like a car, a frame is made, then again the body is given. If you take a building, steel structure will be there, then again the building is constructed. Over the structure, over the frame, the complete product is made. So first the structure. So here also programming your entire program, or the way how program instructions are written, all depends on how the data is organized. So that is giving actually the structure to the entire program. So the way data is organized is, we are calling it as a data structure of the data. So that upon that, the entire application is written. Understood? Is it clear now? Now you tell me, can you develop any application without any data structure? Without knowing about the data structure? No, you cannot develop any application without using data structures. Now, if you are a Python programmer, if you are a JavaScript programmer, you are using data structure without knowing about the data structure, without knowing about them. Maybe. Many people are doing programming in various languages without knowing about the data structure, they are using the data structures. But now as an engineering student, you will study in detail about the data structure, you will learn about the performance of each data structure, you will identify different type of structures, and you will also try to design new data structure. These are the things that you will do. That every programmer doesn't have to do that. But as being an engineer, you must do all those things. So you should know all the basics or the core things, then only you can imagine the higher things easier. Now one more thing I want to add here, just from our previous sessions, one question here related to that. You can easily answer this. What type of data will be inside the stack? You know, when the stack frame is created, whenever function is called. So variables of a function are declared. So that variables are useful only for the function. And when it's gone, the variables are gone. So are they temporary purpose or permanent purpose? Temporary purpose. Temporary purpose. So the variables that are useful for a function for keeping the intermediate results or doing some processing, it utilizes this stack. Then where the data for the entire application should be? Heap. Heap. All the functions, all the objects or classes objects in your application can use that data, means it should be in heap. So that is the importance of heap. All right. So mostly when we talk about data structures that are in heap only, not inside the stack. All right, when we talk about this one. So that's all. I have given you the importance of what is data structure. I have explained you. All right. How to organize the data in the main memory, not any other place. Now, next thing. Now I'll give you the list of data structures. Then also I'll tell you how much you should study data structures and all that. I will cover it next. So from the list of data structures, I'll also be telling you what is the syllabus for GATE and what is important for GATE, what you have to study thoroughly. All right, let us start. So actually, again, it's like a topic. I'm discussing it like a topic. All right. So see. Data structures, I categorize them as physical data structures, and second is logical data structures. I am categorizing them as physical and logical data structure. There are two types of data structures. All right. Under physical data structures, you have array, and the second one is what? Linked list. Array and linked list. These are two physical data structures. All right. Now, why these are two physical data structures? Then what are these logical? I'll come to them. See, you have done some programming already. You have done some programming. So, if your program, okay, not this one. In your program, let us say C program. Okay, let us go it like this. In your programming language, when you are declaring a collection of data, group of data, not just one single value, collection of data, what type of variable you declare? Array. Group of data. All right. Not just one value. We are talking about group of data, large size data. So that's nothing but array. So in the programming languages, it directly supports arrays. Where these arrays are created, they may be created either in array or in the stack, or else you can say star B assign new int of size 10. They may be created in heap. So when you want to acquire the memory in the main memory, acquire the space in the main memory, then there is one method, that is you can declare an array. All right, this is one. Then the second thing is, you can also form if you want to acquire the memory, you can also form linked list by forming nodes where the nodes are linked with one another. I'm assuming that you know a little bit of this one. Even if you don't know, no problem. This is the another method of acquiring memory. Acquiring memory. So you can acquire the memory through your program, either using an array or using a linked list. So these are the two physical data structure I am calling. So let me draw them here. This is an array and this is a linked list. These are the these are the only two methods of acquiring memory from your any programming language. You take any programming language. These are the only two methods of acquiring the memory, right? Either you get an array contiguously or linked list. Take some node and again link and take another node and so on. In this way you can acquire the memory. Now next, when it comes to logical data structure, you have a various logical data structure. The first one is stack. Second one is queue. Third one is trees. Fourth is graphs. Okay, queues. You don't have stacks. You have queues, trees, graphs, and hash table. These are the various logical data structures. Now, what these logical data structures are, let us look at them. Stack is a data structure which works on discipline. LIFO. This works on first in, first out. This is hierarchy. This is like network. And this is just a table. It's a table only. Listen. Stack is a data structure which works on LIFO, means the value that was inserted at the last will come out first. All right. So queue. Okay, let us take queue. From this you can easily understand. Queue means in daily life we form a queue. People stand in the queue. Who came first will be served first and he will go out first. All right, he'll go out first. So forming a queue is nothing but a discipline. It's a discipline. So yes, stack and queue follows some discipline. This follow LIFO discipline and this follow FIFO discipline. All right. Now, next. If you want to implement this queue discipline, means what? Not humans, not people here, but data will follow this discipline. Data will follow the discipline. For example, if you have 8, 3, 9, 4, who came first? 8. 8 will go out first. 3 will go out first. 9, 3 will go out next. Then 9 will go out next. Then 4 will go out next. In this way, they will go out. Whoever came first will go out first. All right. Now the question is, if you want to implement this discipline upon the data, where the data will be present? Where you will keep the data? You will keep the data either in array or in, come on, either in array or in linked list. So if you want to follow stack discipline, then where the data will be? Data will be either in array or linked list. Now, finally, all these logical data structure, logical means just they have the discipline or they have some idea. How you implement them practically is either using array or linked list. Either array or linked list. So in your entire syllabus for GATE also, you will be learning stack using array, stack using linked list, queue using array, queue using linked list, trees using array, trees using linked list, graph using array, graph using linked list, hash table using array, hash table using linked list. So when you pick up when you design any of the logical data structure, that has to be physically implemented using either array, linked list or combination of those. Combination of those. Is it clear? Is it clear? So basically, if you see, when from our program, which data structure you can create either array or linked list. But how you use the data in that, how you use the data, that depends on this logical data structure. Data you store, but if you're using it like a LIFO, then you are using it like a stack. If you are following FIFO, then you are using it like a queue. Or if you are arranging the data in the form of hierarchy, then you are following trees. All right. So physically, there are two data structure, logically many data structure, and even you can define your own data structures also. All right. Now, one more thing. When it comes to stack, there is something called as just a stack. When it comes to queues, you have queue, circular queue, DQ. Multiple topics are there, that's why I have written queues there. Then when it comes to trees, it's a binary tree, n-ary tree, B tree, or B plus tree, heap, complete tree, binary search tree, AVL tree, red-black tree, splay trees. Many types of trees are there. Many types of trees are there. Okay, I have just given the names, but not all in a DS of this syllabus. Okay. So there are many types of trees. Now when you say graph, again there are many types of graphs are there. Many types of graphs are there. Directed graph, non-directed graph, cyclic graph, acyclic graph. Many types of graphs are there. All right. Then hash table also. Hash, it's not tables, just hash table. But how it is organized, there are different methods are there for organizing a hash table. So these are the topics of your GATE syllabus. We start with arrays, then we'll learn linked list, then we'll start stack, using array, using linked list, queue, using array, using linked list, trees, using array, using linked list, and so on. All right. Now, this is the list of topics of your GATE syllabus. Now in this, which is the topic in which most of the questions asked? Trees. First topic is trees. Second topic is graph. Now if you check the previous question, these two combined together completes almost 70% questions. These two. Next is this one. That is hash table. Good number of questions are there in this one. The next comes, okay, fourth, stack and queues. Very few things to ask here. You cannot frame tricky questions here. So they have not used this topic much. Few questions are there. Then fifth one, again here also you cannot frame many questions. So there are few questions. Again, linked list also you have silly linked list, circular linked list, doubly linked list, right? Circular doubly linked list, this type of linked lists are there. But we will cover all of them. But very few questions are there in this one. And finally, array. Actually, array is also there in C programming. The question is asked from array. Now it's hard to judge whether it belongs to DS or whether it belongs to programming, C programming. If pointers, all those things are used, then it is related to programming. All right. If any algorithm or representation is given, then it belongs to data structures. All right. So if you want to take the list of these topics, you can take them now. Do you want to take anything from this? This was a rough picture. You can take this list. When this function is called, activation record is created having the values variables what? X, Y, and Z. It will use them. Once it is over, it has got the result, and suppose it has returned the result, it has returned the float result, suppose its work is over. So all these variables are cleared. So in the stack, the memory for these variables is created, which was just temporary, only useful for duration during the execution of a program, execution of a function. Now I have written one function called add, means adding a number to an array of size n. And what's the number we have want to add? X. So this is called by reference. So whoever is calling should send the reference to this array. Reference to this array. So that array belongs to whom? To this function or to the calling function? Calling function. Okay. Now next question. When this function is called, the pointer is created, n and x are also created, and the function is gone, p is gone, n is gone, x is gone. So all these are temporary, and if it is having more variable, that are also created and deleted when the function over. Now what remains as it is? Array which was passed. Suppose I am main function, I am calling this function, so I am passing a pointer to the array. Alright, so my array is as it is. Function has finished. Do you agree with this? Now I may be passing it to some other function for updating the value. I am passing it to some other function for deleting the value. But the array is as it is with me. So that array now, it belongs to whom? To these functions or to the entire program? Entire program. So usually the variables that you have declared inside the main will remain throughout the execution of the program. So you can say that those variables belongs to, those variable belongs to, once again. Okay. The variables that are declared inside the main function remains throughout the execution of the program. So you can call those variable belongs to complete program. You can say they belong to complete program. Now, if that data is not created just in stack, if it is created in heap, then it's easy for sharing with all the application, but just by sending the pointer. So actually, when you develop bigger application, not in C or any other language you may be developing, indirectly what you are doing is, in your main function, you are creating entire data in heap. Here you will be creating the data. And all the functions will be using this data. All the functions, function 1, function 2, okay. Just roughly I am writing. All these functions will be using the data, and main also use the data. So who will keep the data? Usually who will create the data and keep the data there? That main function will keep the data, and all the function can access the data if pointer is available. So this is how we usually design the application. If you are doing it in C, then you have to do it carefully. But if you are using Java and all, you don't have to do that. Because in Java, for every object, heap only. Every object is created in heap in Java. For everything you have to say new. Everything is going in heap only. Hardly local variables, that belongs to stack. But in C++, you have a problem here. You C++, suppose you have written a class called customer. Okay, so you'll say customer C with the some values, parameters passed. Or you say customer. Okay, just I am answering the question. Please explain the difference between stack and heap once again. Because I said that the data inside heap belongs to the entire application. So I'm answering that one, trying to make it more clear. Okay, see, look at this. From this you can realize. In C++, there are two methods of creating an object. One is customer C parameters. Another one is customer star P assign new customer. Now tell me where this is created. Stack. Where this is created? Heap. So in C++, you have option to create an object either in stack or in heap. But in Java, all are in heap. So if it is in stack, it belongs to the function in which you are creating. If it is in heap, it can be shared easily by whole program by just passing a reference. नहीं बाबा, मैं बार बार बोल रहा हूं. If pointer is provided, reference is passed, then it can access easily. Reference is passed. So it's not accessing my own. Suppose I am main, you are some other function fun. So when I am passing the reference of data from the heap, I am giving you the reference of the data that belongs to application, not my own data. If I am giving the address of my local variables, then you are accessing my data. All right, understood this one? नहीं समझ में आया? आ गया? हाँ. So the point is that the application's data is kept in the heap, and who creates it? Anybody can create it. Anybody can create it. But when it belongs to the entire program, means who should initiate it? In your Java program, who should initiate it? Main. Main should initiate it. So that's why in Java, everything is automatically in heap. But in C++, you have option whether you want it in a stack or... So this is dangerous. No doubt it is giving freedom to the programmer, but the programmer should have the sense that where he should create which type of variable. All right, which data remains throughout the lifetime of a program, which can easily remain throughout the lifetime of a program. One is global variable. Second one is heap. Unless you say I don't want it, it will be there. So the data belongs to the application should be kept in, come on, a heap. Otherwise, otherwise you said just now, one answer you have given, global variable. So its global variable is a good idea. Global variables are written at the coding time only. That are not dynamic. But the heap data can be created dynamically. That's all. आ गया? समझ में आ गया? Actually, this is the point usually students don't realize. Even people who are doing programming, they don't realize this. I have raised it as a point. Especially have raised it. So that application's data belongs to heap. See, if you are opening a browser, let me add a few points to this one. You have opened a browser, Chrome browser. You are loading a page. Page is coming from internet. Lot of HTML images and the other media contents. Where they are now? In the RAM now. In RAM. Right? They are in RAM. Then only it is visible on the screen. But in RAM means of your program. So which part? Stack or heap? Heap. You open a new tab, load another page. Everything is brought again in heap. Now you close the page, release, free memory. Close the tab, again, free the memory. You have opened a notepad. Does the notepad know how much you are going to type? No. You are going on typing. Is it any limit in MS Word or Notepad? Any limit is there? No, you can go on typing it. As long as you are typing, it is there in... it's there in RAM only, right? Once you say save, from RAM it will go into hard disk. From RAM it will be copied into hard disk, but the RAM thing stays as it is. You can go on modifying, add more things to that. So it's in RAM only. Or maybe, so which part of RAM now? Stack or heap? Heap. Because Notepad is not just one main function. It is a collection of functions. So if you are saying find and replace, if you are saying change the font size, or different things you are doing, so that are happening on the entire text, so that it is accessible to all the functions. Understood this one? Is it clear? So all the applications you use, they also keep the data in heap. So that is the importance of heap I have shown you. Now is it clear? So we'll be starting with array and we'll be starting with linked list and so on. Now, one picture I have shown you here. I have shown you this data structure. Okay. Now, one more thing. Do you know there are a lot of algorithms upon known algorithms are there? Many known algorithms are there, like finding shortest path, all pair shortest path, traveling salesperson problem. There are many like that. There are list of algorithms are there, right? And many of those algorithms works upon graphs. Mostly they are on graphs only, or trees and graphs. Let us take them like this. What is the use of this in the browser? Just now we have spoken about browser. What is the use of this in browser? Those algorithms, shortest path, traveling salesperson problem, all those things you have seen, you know about them. Are they applicable here? How? Okay, in Notepad are they useful? No. Okay, Notepad are they useful? Notepad? No. Calculator? No. Many applications are there in that. These are not useful. These are not useful. Then what these algorithms are that you study? What these algorithms are? Actually, those algorithms are not related to data structure. Not related to data structure. Those algorithms are just for problem solving. If you have a problem, similar problem, then you can solve it using these known algorithms. So problem solving is an entirely different thing from programming. It's no way directly related to programming. Problem solving is a different thing. Like even in our daily life, if we come across any problem, we'll ask our elders or ask our seniors, and just we put a problem in front of them. They say that this problem came to me and I did like this, and we follow that. So they know the procedure, we follow the procedure. These are mathematical problems. These are mathematical problems. So in daily life, we have problem in various domains, but the problems related to mathematics are nothing but that are related to graphs and all. So those algorithms are related to problem solving, not directly related to programming. Understood this one? Understood this one? Is it clear? Now let me add a few more things. If you are solving a problem, that is writing a program for shortest path, then you should have a graph. You are writing a program, so you should have a graph. Graph may be either in array or linked list. Then over that you write the procedure using a program for solving the problem. Now graph is nothing but data. That data should be in the form of array or linked list. Then over that you write a program. Understood? So problem solving can be done using pen and paper as well as using programming. Two different things. Problem solving can be done using pen and paper as well as through programming. Now you tell me how many different problems are there in the world and how many solutions are there? Limited or infinite? So problem solving is infinite, not finite. Problem solving is infinite. Got this idea clearly now? Understood? Is it clear? Now, coming to data structures, finite or infinite? Finite. Data structures are finite. So DS is finite. Now, when you are saying algorithms, means that are useful for solving problems that are infinite. If you write DS, you are writing something which is finite. Once you add A to it, then the entire thing becomes infinite. So don't add A with DS. First you finish this finite thing, then A takes lifelong journey. From A, there are some known algorithms which are you are learning in discrete mathematics, you are learning in operating system, you are learning in CO, you are learning in separate subject like algorithms. You are learning few algorithms. Now, if you want to learn more and more, there are many algorithms that you can learn. All right. Those algorithms are used, that can be solved or followed by using pen and paper. That is nothing but problem solving. And for the same thing, you can write on the program. So it is nothing but converting an algorithm into a program. Converting an algorithm into a program. Right? That algorithm may belong to your domain, may not belong to your domain. Do you agree with this? For doing a surgery in medical science, doing a surgery, procedure is there or not? That is also an algorithm or not? You write a program. Can you write a program? Yes. But it is a physical thing, so you can put it in the robot. That robot will perform the surgery. So medical science, do you know? Do you know medical science? Are you a medical student? No. But the algorithm, who will write the program for it? Someone who knows programming. Someone who knows programming. He will write out the program. He will teach. Surgeon will teach how to do it. He will understand, then he will write a program, then they will test it on various things. When it's perfect, they will put it in on use. This is how things works. So for learning algorithm, there are various domains and you have to get the domain experts and all. Now to this, I will add one more point, that why Python become famous? Easy to learn. So easy to learn for domain expert. If I am doctor, and I want to write a program, I can learn Python and write a program. If you ask me to learn C programming, it will take 6 months, 1 year for me to get master in C. Then writing my program in C, it's very difficult for me. So for domain experts, they have brought a language, that is Python. So if you are a accountant, learn Python and do your work in Python. All right. So that's how. Easier languages are not for the professional, engineers. That are for professionals, domain experts, other domain people. All right. Is it clear? Like a car is there. Automatic car, self-driving car. You don't need a driver. That is for whom? Those who don't know driving. Those who don't know driving. And they don't want to learn driving, just they want to focus on their own work. Their own work. Okay, those who know driving, who is a mechanical engineer, then he should know everything. So that's all. In IT also, you should know everything if you're an IT engineer. All right. So that's all. Is it okay? I'm just discussing a general things. Okay. So, one more thing. So problem solving, I told you. Now, when you talk about DSA, you remove A. DS. So you should know about all these data structures thoroughly. All these data structures thoroughly. All right. You should know what these data structures are, how they work, and what is their performance. You should know this. And you can do it also by, you can also implement it using some programming language like C, C++. All right. So that's what in academics mostly students do. And for the same thing, it's there in GATE also. Because they teach you in academics, we teach how to write your own code for implementing these data structures, stack queues, all these things. Understood? Now by using them, you are solving various different problems or small problems. We are not talking about a big application, just problem solving, just a small problem. All right, solving those problems. This is a continuous work. So in your syllabus, in your engineering syllabus, you have limited algorithms. You don't have every type of algorithm coming from mathematics also. All right, few algorithms are there. Now coming to one more thing. Recently, there was a boom of DSA. A lot of, still it's being at boom that many companies ask for DSA. So they ask DS and A, that is infinite. So for this, you go for competitive coding, competitive programming. In competitive programming, you have A, not DS. DS, you will be utilizing it, but mainly A. You learn this trick, that trick, so many tricks are there. You will be go on learning and writing the programs and you will try to solve the problem. That's all problem solving, nothing else. All right. Now, if you're going for a job through campus interview, what is sufficient? DS is sufficient. DS is sufficient. All right. If you are going in open competition, then you should know A also. Now for working, means somehow you are at work now. You are at work now. So for working, what is useful? DS is. The knowledge of DS is enough. Knowledge of DS is enough. All right. So that was the entire discussion. One more point I wanted to add to this. One more thing. See, you have learned data structure using C or C++. Most of you using C. In C++, there is something called as STL. What it is having? All the classes for data structure. Built-in classes are there for data structure. Can you name few? Vector is famous. Vector is there. Linked list is also there, right? Linked list or just list, I think. Yeah, it's list. It's list. List, map, set. In Java, you have built-in data structures like that is called as collection framework. Under that you have array list, linked list, set, tree set, map, hash table. I'll write it as hash table. This is a old class, I think. Hash map, hash set, all these are there. All right. You have stack or queues also there. Stack is there here. You have stack here. And you have DQ also, no? No, here you have DQ. Yeah, here also you have DQ. Here also you have DQ. DQ. All right, listen. Pair. Here you have entry. Similar to that. Python is having list, set, tuple, dictionary. These are all built-in data structures available in these languages. So in C language, do you have built-in data structures? No. That is the reason in academics, usually they use C language to teach how to develop your own data structures. If it is taught in C++, Java, Python, means there is no fun because already they have built-in data structures. Why do you create yours? If you really want to do it at a lowest level, you can do that. You can do it in C. Otherwise, you can do it in C++ also because similar syntax is there. No doubt you have STL, but still you can use C++ also. But using Java for developing data structures and Python is no fun, no meaning. Okay. Now, can you tell me what is this? Array. What is this? Linked list. Linked list. What is this? Hash map. Hash map. Tree. Tree. Binary search tree. Binary search tree. Q, stack, DQ, same. Array list, linked list, set is tree. Binary search tree. Binary search tree. And this is again binary search tree only. This is actually superclass. This is subclass, I think. Map. This is a table. Hash map is also a table, hash table. This is a hash table. So they have built-in classes. Now listen. Now listen. As I said, this is a tree, or this is a binary search tree. This is a binary search tree. Now listen. Why you should know data structure when you already have these built-in classes? When you have these built-in classes, why you should know data structure? Okay, you should not learn data structure, but you should know in detail about these classes so that you use the class at right place. Depending on your problem, you should use a perfect class. So you should know about all these classes in detail. You agree with this or not? When you try to study these classes in detail, you are learning nothing but data structures. Except programming part. You are not developing your own. But when you are developing and checking everything thoroughly, then you are doing it in much detail. Otherwise, just you go to documentation of this STL classes or this Java, they will tell you what they have used internally, what is the time taken for inserting a value, what is the time taken for deleting a value, all these things they will tell you. So if you in turn learn about these classes in detail, you are learning about data structures only. Once again. Alright, if you know about the subject, then you can utilize these classes perfectly. Now without this, there is no programming in Java. Without this, there is no programming in C++. You can write simple student programs only. Finding a number is prime, checking a number is odd or even, prime or not. Right? Simple programs you can write. You cannot develop application. When you are developing application, you need these classes. So without knowing these classes, you cannot use the application. Sorry, you cannot use the language perfectly. All right? Is it clear? See, Python, acha, you know this STL, you have learned C++. When you have learned STL, during learning of C++, in the beginning or at the end? You have learned C++, so STLs you came across that topic when it was started, at the end or in the beginning of C++ only. And some places not covered also. Right? Acha. Collection framework, you started learning Java, writing first program, then so on, learning. At what stage you will come across collection framework? After learning OOPS and all, you will come across it. So it's a long journey to reach collection framework. Python, first class, second class. In first, you will learn about int, float, all this. Then after that, followed by that second class. So these are the data structure which are given to you in the beginning of the language itself. So how easy this language is? Understood this one? So for reaching the same thing, you have to cross a journey of 3 months, I think, if you're learning proper, going through Java training. So it may take 2-3 months, then you will reach this topic. Or 1.5 months, you will read this topic. All right, this is first or second day itself, you learn about this one. But you may not be knowing all the details of this one, like how much time it is taking and all. You will see that dictionary key value, go for dictionary. All right, no duplicates, go for set. You know that much only. But how that set is implemented internally, you don't have to know that. So you don't have to know about the data structures used for using this particular language. Sure. Over. I have given you the overview of other languages also, like showing you the importance that data structures are available in all the languages, and it's not there in C. That's why we developed the data structure using C language. Now let us start our topic with arrays. Now in this, in GATE questions, GATE syllabus, it says arrays, that's all. What they will ask, we don't know. How much you study, we don't know. So from the previous questions, we can make out in what direction they ask questions. So mostly they ask question in arrays from array representation, array representations. Second one is operations on array. Or they will ask some these are the three things. They have asked questions upon representation of array. Okay, note down, then I'll show you. Upon these three things, they have asked questions mostly. What these are, I'll tell you. See, representation, that is row measure, column measure representation, how the arrays are handled by the compiler. Based on that, they have asked questions. So we'll discuss that topic. Second thing is operations on an array, that is insertion, deletion, checking whether it is sorted or not, or merging two arrays, right? Appending, rotating an array, reversing an array. Upon these type of things, they have asked some questions. Just in words, they have described something and asked the question without giving any code or anything. Second, third type of question they have asked, they have given the code which is doing some processing, that is an algorithm doing something, and asked what is the output or what this algorithm is doing. Okay? So there are three type of things they have asked. Now when it comes to algorithm, now you can say the question belongs to the subject algorithm, which is infinite again, what they can frame. So you don't have to worry what they will ask. Mostly they will give you the code and then ask you the question. So you can easily answer those type of questions. So you don't have to learn many algorithms beforehand. All right, you don't have to learn. So let us start with first topic, that is array representation. So the first topic is array representation. See, this topic is based on actually compilers. How compilers handle arrays. The topic is how compiler handle arrays, how they manage arrays. In your program, let us say in your C program, if you have created an array of a size 5, then you know very well that an array of a size 5 will be created of type integer. Let us say that integer takes 4 bytes. Integer takes 4 bytes. Now, this is index 0, 1, 2, 3, 4. Then you know what the addresses are. For example, we start from 2000, this is 2004, and this is 2008, and this is 2012, and this is 2016. These are the addresses. Now listen. When you are saying you want to store a of 2 assigned with value 15, so at this 2, value 15 will be stored. Now, the question is, when you have written a of 2 assigned 15, in this place, the compiler will generate some machine code, right? It will generate the machine code. which will store 15 at that particular index, So what is the method used for getting the address of that particular location? How compiler will get the address of that location and then it will store 15. So the question is, how compiler will obtain the address of A of 2? For A, what is the address now? 2000. But for A of 2, how it has obtained the address? So that's what we are going to learn. So first we'll start with one-dimensional array, then we'll talk about two-dimensional array, then also three-dimension, then for n-dimension also we'll see. So watch this now, I'm explaining. See, the base address of an array is called as location 0 or L0. Location 0, L0, base address. Now what the compiler need is address of A of 2. Watch this carefully. So that, see, one thing. Here you don't have to copy, not just in this topic. You have to understand the topic the way I am explaining. So once you have understood, you can recall it easily. That I guarantee you. You can recall it easily. So listen carefully. So the way I am putting it on the board, you can easily recall it later on. Alright. So listening is more important. Then later on you can note down. Watch this. It needs the address of A of 2. So for knowing the address of A of 2, the base address is already known. That is location 0 plus. Actually it is 2008. Right. So it has to go to this one. So right now location 0 means it's at 2000. So it has to move 2 locations away, 2 integers away. So 2 integer means 2. This is 2. But what is the size of the integer? 4 bytes. So into 4. So this will be how much? 2000 plus 8. This is 2008. Wait a minute. Alright. So location 0, that's the base address, plus index is 2 is given, 2 into size of integer, that is 4, so it has obtained the address. Now, in the same way, how it will get the address of any location A of I? For getting any location A of I, it will take the base address, that is location L0, then I into whatever the, see, this is integer, so we are saying 4 bytes. It may be float, that is 4 byte. It may be character, just 1 byte. It may be double, that is 8 byte. So whatever the size of the data type, let us call it as W. So this has become a general formula for any index or for any type of array. Any index and any type of array, not just integer. So this is the formula. This is the formula used by compiler for accessing or getting the address of any location that you have given. So internally, when you say A of I, it will replace with base address plus I into W. When you say A of I, it will replace like this. And the machine code is written for this one, for getting the address. At that address, it will write on that data, 15, whatever you have given. Understood this one? So through an example, I have explained you. Right, so you don't have to remember the formula. You can remember it. If you forgot also, you can take an example and quickly get this one. You can take this. So we are talking about 1D array. Any question from online student? over. See, if I have to count, I'll count like this: 1, 2, 3, 4, 5. I started from 1. 1, 1, 2, 3, 4. In daily life or in mathematics also, we start from 1. Never we start from 0. But you know that array starts from 0. In C language also, Java also, Python also, wherever you go, array starts from 0 only. What could be the reason? Okay. So that answer I'll give you. Is it okay? I have reduced the size and kept it here instead of going on next. Now, in some languages, there was a method like you can say, for example, I am changing this one integer a 1.5. You can create an array by giving the lower index starting index and ending index, lower bound and upper bound, starting index and ending index. You can give them and you can create an array. So here we have given size 5, so it has given the indices started from 0, 1, 2, 3, 4 last. But here you can give the indices like this also in some languages. All right, not in new languages. In earlier old languages, this was possible. So when this is done, then how the array is created? Okay. 1, 2, 3, 4. And this is 1, 2, 3, 4, 5. And if you take the addresses are, let us say, same: 2000, 2004, 2008, 2012, and 2016. Now, when you want to access any location, let us say you want to access any location, A of 3, assign value 15. So you want to store value 15 here. Then how to obtain the address of that? With the help of this, we will get the formula. Address of A of 3. I just wrote ADD for address. Address of A of 3 is what? This is L0, right? Location 0. L0 plus what? 3 minus 1 into 4. 4. Let us take integer is taking 4 bytes. So what is the address? 2000 plus 2 into 4. This is 2008. 2008. You agree with this or not? Understood this one? Now coming to the next. For any given index, A of I, what could be the formula? L0 plus I minus 1 into whatever the word size. W is word size, means the size of the data type. If you are saying integer is taking 4 bytes, integer 4 bytes. If I am taking integer 4 bytes, just watch this. So this has become the formula, that is address of any location A of I can be obtained by L0 plus I minus 1 into W. If the array indices are starting from 1 onwards, then this is the formula. If they are starting from 0 onwards, then this is the formula. L0 plus I into W, L0 plus I minus 1 into W. Now you tell me which formula is faster, having less computation. The one is starting with 0 onwards. This is little slower because it is having one extra operation, that is minus 1. One extra operation. All right. So listen. Here the array size is just 5. If it is 500 or it's a very lengthy array, then for accessing each location, one instruction extra. Just for one location, okay, the one instruction is extra, means it's not a big thing. But array means collection of values. So whatever the size of an array is, for accessing every location, compiler will use the same formula every time, I minus 1 into W, I minus 1 into W. Whenever you are saying, see, suppose you are writing for A of I, for every A of I, it will be using that formula. So that is much time consuming. when it is coming to a longer size array or bigger size array. And this is faster. So one single operation also matters when it comes to accessing large size arrays. All right. So which is faster? This method is faster. That's why in old languages, in Pascal, it was possible. You can start the index from anywhere you want, anywhere you want. But now, afterwards, C language onwards, everything is 0. So array index is starting from 1 onwards. Array index starting from 1 on. This was from 0 onwards. That is from 1 onwards. Suppose in some language, oh, okay, same language, like some language, array indices are allowed from any index onwards you want. Suppose I am declaring an array that is integer a, starting index is -3 dot dot, ending index is 5. Now, what will be the formula for this one when the integer size is, oh, okay, what will be the formula for this one? Write down. No, no, write down, write down, write down. I don't want quick answer. You take it, draw it, and write down the formula. The procedure, what I have done here, you follow the same procedure and come up with the formula. That was from 1, but this is from -3 to 5. I have created an array. Lower bound I have given -3, upper bound as a. So when it is allowing me to give any starting index, means it's allowing me to give negative indices also, suppose. So even negative indices are allowed, then formula. It's bigger than those. That is 5, that is 5. But this is how much? 6, 7, 8, 9. Array size is 9. From online student, any answer? See, for online student, your chat window is on this side, on my right hand side. When I'm going on this side means I'm reading your chat. आ गया? हाँ. What is the address of any location A of I L naught plus I plus 3 into W? I minus lower bound. I minus lower bound. So that become minus into minus plus. I plus 3 it becomes. For getting this, if you have any confusion, this one, instead of directly getting it, you can try this. I have taken some index like 3 and I found out the address. Now from that I can easily figure out this one. So if you are taking one example, then you try that one, you will get to know. Take -1, you will know that what will be the address, how you get the address. Then you can get the formula perfectly. Now one more thing. Starting index is 0, ending index is 4. So what is the size of the array? 4 minus 0 plus 1. So this is 5. Starting index is 1, ending index is 5. So 5 minus 1 plus 1. So this is 5 only. What is the size of this array? Starting index is -3 and ending index is 5. 5 minus -3 plus 1. So this is how much? 5 plus 3 plus 1. This is 9. To know what is the size of the array based on the starting and ending index, you can subtract the lower bound from the upper bound and add 1, you will get the size of an array. Why adding 1? All places, including that index also, including 0 also, including 1 also. If I say 5 minus 1, I'll get 4, but actually 1 is also included. All right. Now we'll move to next, that is 2D array representation. 2D array representation. If I am creating an array A of size 4 by 5, then array is created like this. And if you take the indices are, this is A, 0, 1, 2, 3, 0, 1, 2, 3, 4. If I write the addresses, this is 2000, this is 2004, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 40. Now, I'll make a change here. Okay, this is gone. Look at this. Now, this is empty. Let us put some data in this one. So instead of writing numbers, I'll write down something like this. This is A00, A01, A02, A03, A04, A0, A10, A11, A12, A13, A14. A20, A21, A22, A23, A24, A30, A31, A32, A33, A34. Watch this. Watch this. Now we know, see, this is a two-dimensional array having some data. All right. Now we know very well that the memory is allocated contiguously. So what is the dimension of this one? 4 cross 5. Let us call this as M and let us call this as N. So total how many? 4 5s. 20 spaces are allocated. So I'll create an array of size 20 here. Array of size 20. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19. Array of size 20. Now this is 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 and 19. Now if you know what are the addresses are, so let us say this is base address 2000 and this is 2004 and this is 8 12 16 20 24 28 32 36 40 44 48 52. Am I right? 56, and this is 60, 64, 68, 72, 76 addresses. Now listen. When we create a two-dimensional array in our programs, in our programming language, then actually two-dimensional array is not created. Single dimension array of size m cross n will be created, and the data that you are going to store in two-dimensional array is mapped on a one-dimension array. So how it is mapped? There are two methods. One is row major mapping, or also called as representation, and the second is column major mapping. So row major mapping means data is copied from this row by row. It is copied row by row. So I will write down the data here. So this is first row is what? A00, A01, 02, 03, 04. That was 24 I wrote there. This is 10 11 12 13 14 20 21 22 23 24 30 31 32 33 34. This is how the data is filled. If you observe here, this is row 0 and this is row 1 and this is row 2 and this is row 3. Row 0, row 1, row 2, row 3, all side by side. In C programming also I have shown you the addresses that are lying just beside one another. I have shown you that, and we have used pointers to move in between those addresses. We have done it. But now, how compiler will handle it? Not like a pointer. It will not handle like a pointer. It will use the formula for getting the address of any index. For example, I want to get the address of a particular index. Let us say I want to know the address of A of 2 3, second row, third column. So first of all, it should take what? L0, location 0. L0 plus what? So 2, 3 is at which place? 2, 3 is here. So 2, 3 is here. So what should be the address? 2000 what? No, 2052. 2052. We should get the address 2052. So how compiler will get the address 2052? Location L0 is 2000 only, right? So 52. So first of all, it is saying second row. So it should skip first row, sorry, 0th row, first row, then only it will go into the beginning of the second row. So 2 rows. But in each row, how many elements are there? Depends on number of columns. Into 5. 2, 5, 10. Right now L0 means here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's here right now. 2 into 5, 10. So it's here right now. From here, that is in the beginning of the array. This is very important to visualize. When you set 2 into 5, so actually L0 means beginning of the row 0. When you add 2 into 5, 10. So 2 rows means it is beginning of the row 2 index. Right? Now here we have to go in third column. So 1, 2, 3 plus 3, and this thing should be multiplied with what? 4 size of the integer. So how much it is? 2000 plus 10 plus 3, 13 into 4. How much it is? 52. 2052. This is how it will get the address. Just wait a minute. 2052. Now it means for any index a of I comma j, what is the formula? L0 plus what? I into m into n. Dimensions, I have given the names to them. M cross n. So this is I into n plus j multiplied by w. Compiler uses this formula for getting the address of any location by using the base address of an array, and this formula is following the row representation. So this is called as row major mapping formula. Let me complete. Row major formula. Right? Now in this formula, out of these 2 dimensions, first is not used, second one is used. So when we were discussing in C programming, when you are writing the parameter to a function fun as a 2-dimensional array A, it's taking 2-dimensional array, then which dimension you must mention? Second dimension. Because the first dimension you have to skip that one. And that is not used in the formula also. That is not used in the formula. For formula, second dimension is important. First is not important. That's why they made a syntax that you should skip it. You should not mention it. You should skip it. That's why they have made. If you're writing this also, it means you are declaring it. It's not a parameter. Ambiguity will be there. So they said that you should skip it. And that is not used in this one. If you have multiple dimension, you should mention all. The first one you should not give, because that is never used in the row major formula. So as I said that time, I told you that there is another reason why this should be skipped. Now you can see that it's not used in the row major formula. This is row major representation. Now you have to write a formula for column major representation. So I have taken 3, 4 by 5. You can take 3 by 4 and draw it. So how you have to fill up this data? Column by column you should fill up and get the formula for it. Column by column you should fill up. And see, I have not blindly written the formula. I have written this data from this observation by some example. From that observation I have written the formula. Same way you do it. So that if any other thing is asked, then also you can design the formula and write it. Otherwise, if you are directly writing it, maybe you are able to write, but for any other question, you may not be able to do it directly. So go through the procedure. Then you can answer other question also, similar type of question also. Ah. W is the size of the data type. We are taking integer array, so now I am taking integer data size as 4. Our float is also 4. Whatever the data size is. Character, it's 1 byte. So W represents the letter W means word size. Word size means size of the data type. You got the answer, Srivatsa? Ah, yeah. This is a row major formula. Now, column major formula, you are deciding it, right? Column major formula. You will be telling me what is the column major formula. Address of any location A of I comma j is what? L0 plus, louder. J into M plus I multiplied by word size. The entire thing multiplied by word size. Hmm? Now here itself I'll ask one gate question for you. So you have given formula for row major mapping as well as column major mapping. You have done it, right? So now, two D arrays are useful for matrices, right? Matrices. Now listen. I'm preparing your mind and I'll ask gate question. Okay? So you should give correct answer. I'll not give options. Listen carefully. if a compiler is using, let me discuss few points after coming to the question. Okay. If a compiler is using row major, sorry, a compiler, if it is using row major, then it doesn't use column major. Compiler will use any one, either row major or column major. So if it is using row major for getting the address of any a of I comma j, always it uses this formula. For every a of ij, it uses this formula. So in a double for loop, like when you access, how you access two-dimensional array, you use two for loop, right? For integer I assign 0, I is less than m, and I plus plus. Then here you write for j integer j assign 0, j is less than n, j plus plus. For accessing two-dimensional array, you use two for loops, right? So, and you are accessing a of I comma j, whatever you are doing with this one. So for every location, it uses m into n times this will execute, right? M into n times this will execute. For every m into n time, for every location, it uses this formula. Confirm, confirm, confirm. Chalo. If it is using column major, then it uses this one. Now C, C++, Java, all these languages, they use row major only, but column major is also possible. But compilers use row major only. Now, next. Which one of this is sufficient? Which is faster? Which is efficient? Now, efficiency, you don't know what is I, J, M, N, you don't know. How do you measure the efficiency now? Don't take small m and large j, large n, don't do that. So, just based on the operations. Number of operations, is there anybody faster or slower? No. Both are equally efficient. Both are equally efficient, both are same. Alright? Understood? Understood? Now gate question. Now gate question. You should not give wrong answer now. If I have a matrix A and matrix B, then I want to get matrix C by multiplying two matrices A and B. Then which of the method will make it faster? First one is option A, A in column major, B in row major. A in row major and B in column major. You know matrix multiplication. C both in column major. और एक D कुछ है ऑप्शन, भूल गया मैं. I forgot that. I have written the option. D I forgot. Now which one is correct? B. मैं बोला गलत आंसर नहीं देना बोला. B for हाँ, B for बॉम्बे. हाँ, ये गेट क्वेश्चन है. I have explained you everything, then ask question. And you are giving correct answer, wrong answer? Wrong answer. Chalo, once again, what is the answer? Once again, all of you. D. D. What is that? D is? D मैं तो भूल गया ना, तो आप बोल सकते हो ना. Independent of? नहीं, independent of any representation. Independent of any representation. Fourth option is independent of representation. Intentionally I left it so that you give wrong answer. अगर वो लिख दिया तो आप क्विकली बोल देते थे independent of any representation. इतना समझाया ना मैं. So intentionally I left it because see, once you listen to the question, once you read the question, you get the idea that matrix multiplication means this one. So you think that if this is in row measure, this is in column measure, that will be faster. No, for every element, it uses this formula only. Either this formula, if you're saying column measure, it will use this formula. And both the formulas are equally efficient. Nobody is faster, nobody is slower. So whichever formula it uses, doesn't matter. And one more thing I told you, compiler always uses the same representation. They will not switch in between the representation also. So everything I told you, just miss the last one. So there was some confusion still. But you could not figure out what could be the last one. So the last answer is what? Independent of representation. So this was a tricky question. Once you read the questions, you will get the answer as B. Alright. So DS questions are like this only. Data structure questions are like this only. Tricky questions. So you quickly get the answer. And most of the time it's wrong. Here you don't have to come with just concept, you have to apply, nothing else. There is no code. Based on the concept only questions are there. Independent of any representation. D. So you can write down if A and B are the matrices and you want to multiply them and get the result in C, then which type of representation of A and B is more suitable or more efficient? A, B, C or D? Over. Shall I change the slide? Now, for the same two-dimensional array, for the same 2D array representation, 2D array, if suppose in a particular, in some language, you are having an option to give the indices starting from 1 onwards to suppose some m and to some n, then what will be the row measure formula? Shall we do it directly now? Address of any location A of I comma j can be obtained by, you have the idea now, so you can do it. Plus I minus 1 into n plus j minus 1 into size of the data type. You agree with this? From I also subtract 1, j also subtract 1. Lower bound you subtract for both of them. And if the lower bounds are different, whatever the lower bound you subtract it. Formula is same. Understood this one? I minus 1, j minus 1. Rest of the things are same. See, this was n, not m. This was n. And column measure also you can write down. This is row measure formula. This is row measure. You finish column measure formula also. I have one GATE question. This is an old GATE question, simple one. Here is a GATE question. If there is a two-dimensional array starting with indices 10 and 1 to 15. So you can see that the indices are starting from 1 onwards. Assume that, okay, of type integer, and assume integer takes 1 byte. Integer takes 1 byte. And location 0 is 100. What will be the address of A of I comma j? Address of I comma j. This is the size of the array. This is the dimensions of an array. You have rows also, you have columns also, you have location 0 also. And row major formula is used. So what is the address of this one? Row major, I have not mentioned. Row major formula you have to use. Row major formula. You have to use row major. What will be the address of A of I comma j? So in this, you know L0 and M and N, just you Ij, you don't know, you keep them Ij as it is and get the answer. So you get a formula, right? You get a formula and that you put everything, I and j remains as it is. Take your time, solve it and give the answer. It's a simple question only. नहीं, ये सॉल्व नहीं करे सही. L0 is 100. Okay, you got the answer. What is the formula? See, this is the formula that you have to follow because the indices are starting from 1 onwards. So this is address of any location A of I comma j is L naught plus I minus 1 into n plus j minus 1 entire thing into W. Same formula I have copied here. This is row major formula. Now for knowing this address, he's asking us to find out the address. L naught is how much it's given here. That is 100 plus I minus 1 remains as it is because we don't know what is I and j. N, this is M cross N array. N is how much? 15 plus j minus 1, which don't know j, it remains as it is, and whole thing multiplied by 1. Now this is 100 plus this entire thing is 1, so it remains as it is. So let us multiply this 15 into I, 15I minus 15 plus j minus 1. So if you take, sorry, from 100 you subtract 15, so it will be 85, you subtract 1 also, it is 84. 84 plus 15I plus j. This is the answer. So as we don't know I and j, we did not get the exact address, but we got the simplified formula. This was the actual formula, we got a simplified formula. ब्रेक लेंगे या ठीक है 10 minutes break. We'll take 10 minutes break. Yeah, online student have answered it. One of you have answered very good. Ramesh, yes, that's correct. 85 you wrote. No, it's Ramesh, it's okay. At last you have minus 1 also. You have not done it. Okay, it's 84. Correct. Next is 3D 3D array representation. Suppose you are creating a three-dimensional array A, 2, 3, 4. Just you have to listen, take the heading, wait, understand, then you copy it. Take the heading and just wait. Don't copy anything. See, when you have two-dimensional array, you call this as a row and this as column. A row measure means first this one, then column measure means first this one, right? Now, coming to three dimension, what do you call to these? This is column and this is row. This you can call it as plane. Plane. Plane, row, column. If you want to see the picture of this one, we can draw it like this. Actually, three dimension, we can't see all the sides. So let us draw it like this. 3 rows, 4 columns. Watch this one. 3 rows, 4 columns. 0, 1, 2, 0, 1, 2, 3. This is A. And this is plane 0. Plane 0. Three rows, 4 columns. 0, 1, 2, 0, 1, 2, 3. And this is plane 1. Plane 0, plane 1. I am showing this. Otherwise, I should draw a cube for it. So plane wise, I am showing. This is plane 0, this is plane 1. Alright. Now, when you have a three-dimensional array also, or when you are creating a three-dimensional array also, you will get a single dimension array created. So what is the size? If you call this as L cross M cross N, then what is the size of the array? 2, 3, 6, 6, 4, 24. Array of size 24 is created. Array of size 24 is created. Alright. Now for this also, for any dimension, it uses the same row measure formula or column measure formula. So for this, what is row measure formula or row measure mapping formula? Now you can take some values, put them here and check them, and then you can write down the formula for it. Alright? Alright? Otherwise, I'll show you the formula. For knowing the address of any location A of I, j, k. I, j, k. Watch here. I'm writing formula. I, j, k. Right? 3 dimensions are there. So this is L0 plus I into. Listen. When you say I means plane. Ith plane. 0th plane means same. This one only. Plane 1 means next. Plane 2 means next. Like that. Ith plane. So how many elements you have to move ahead? Each plane is having how many elements? M into n elements. Right. Ith plane means you have to move M into n elements. Right. plus. Now rest is what? J into J. Row number, jth row will have how many elements? That number of n elements. J into n plus k. This entire thing multiplied by W. So instead of putting in the bracket, I'll just write it open. I into M into N. All right. Now wait a minute. Finished? Understood this one? I into M into N. Both the dimensions are. So for I, okay. First dimension is L. Second is M. Third is N. So for I, we are taking other two dimensions. For J, we are taking the last dimension. For K, nothing is remaining. This is row major formula. Then, what is column major formula? What is the column major formula? Address of any location A of I comma j is what? L0 plus, tell me, K into, look at this. I have not written K here. IJK is L0 plus. Look at this. When you have IJK, here I will show you. When you are having row major means you should go in this direction. Column major means you should go in this direction. That's it. Row major means left to right, column major means right to left. So this is three dimension, 4 dimension, 5 dimension, n dimension. For any dimension, the rule is simple. Row major means you should take IJK. Column major means you should take KJI. Reverse. All right. So now tell the formula. This is what? K into, when you are taking in this direction, so you will take what? Except K, you will take LMN. LN. Sorry. Plus J into L plus I multiplied by W. Take this one. Row major formula, column major formula. Row major means left to right, column major means right to left. If you have in geometry, you will have 3 dimension x, y, z. You can use those coordinates x, y, z. All right. Next. हो गया? Completed. इसका ट्रेसिंग किस ये बनाना पड़ेगा, ये बोल रहे हैं आप? बहुत लेंदी होगा ये, आप करके देखो उसको, इसलिए आइडिया दे दिया मैं। वो एक एग्जाम्पल लेके यू शुड गेट द सेम एड्रेस, दैट्स व्हाट यू आर सेइंग ना, ऐसा ऐसा बोल रहे हो ना, so it will take a lot of time. Now the question is, how to remember the formula? How to remember the formula? This is the question. Previous formulas you remember with the tracing. With the tracing you can recall. Now in this one, tracing is not easy. I have just given you the idea if you want to do tracing. So on the next slide you watch. Now look at this. Just watch. ND array. N dimension array. Integer array. So for this, we will take an example. We will take an example of 4D array. For understanding ND array, we want to get the formula for ND, any dimension. For n dimension, we want to get the formula. 2D, 3D, it was a simple formula. For n dimension, there's a bigger, little complex formula. So for getting that idea, we will make a 4D array formula first. This 4D formula will help us understand 3D also. 3D formula just now you have written. Watch this. Watch here. I am creating an array of array A of a dimension D1, dimension D2, dimension D3 and dimension D4. ठीक है? Now, address of any location A of I1, I2, I3, I4. I1, I2, I3, I4 I have taken. D1, D2, D3, D4, those are dimensions. These are indices. Instead of taking I, J, K, L, M, N, we are not taking different letters. Just letter is same, indices are different. So with indices, you can easily identify what it is. So the address for row major formula, row major, for finding the address since using row major formula, L0 plus. Row major means what? You should go from left to right. L0 plus I1. Watch here. I1 belongs to D1. So you multiply all the dimension except after D1. So D2 into D3 into D4 plus I2. Go to I2, dimension 2, and you multiply all the dimensions after D2. So this is multiplied by D3 into D4 plus, now next is I3. So go to dimension 3 and multiply all the dimension after D3. So that is D4 only plus I4 lastly. And this entire thing except L0 should be multiplied by W. Then column major. This is column major. Address of any location A of I1, I2, I3, I4. It's what? L0 plus. See, when you say column major, it should be from right to left. Just follow this one. So here we will say first I4. Go to dimension 4, except dimension 4, multiply all the dimensions on its left hand side. So this is, you can say D1 into D2 into D3 plus, after I4 you have to take I3. I3 multiplied by D2 into D1 plus I2 multiplied by D1 plus I1, and this entire thing is multiplied by W. Wait a minute. आ गया, समझ में आ गया? Is it clear? Now, for n dimension, what will be the formula? N dimension. A of I1, I2 goes on to In. What is the formula? L0 plus I1 plus I2 plus I3 plus I3 plus all i's are there. Plus means sigma. Sigma. Now we'll take something called as a P that starts from 1 to N. So this is IP. Is it okay? Subscript is P. Now every I is multiplied. Multiply means what? Pi. Product. Product of what? D dimensions. Whatever I is, this is 1, so it starts from 2. If it is 2, it starts from 3. So we are saying this is P. So this starts from 3 plus 1. So I'll give it as Q, dimension as Q, and that Q starts from P plus 1 multiplied by W. Summation means sigma. Product means pi I have taken. Okay. For row measure I have written, column measure. This is for n dimension. This is for n dimension. You write down for column measure. So actually you have to say decreasing. This is 4. So 3, 2, 1. Or else you can go increasing also up to 4 minus 1. Row measurements left to right, column measurements right to left. Now for column measure, you can make generalized formula for n dimensions. Over. Now I have a gate question. Question looks tough, difficult, but I don't want quick answer. When I say answer, then only you should answer, and I am sure everybody can answer it. Okay, I'll give you time. Everybody should answer it. And so it's not tough. It's very simple and easy. Just relax, think a little bit, just use common sense or simple arithmetic and give the answer. Okay? There is a two-dimensional array. It's a gate question. There is a three-dimensional array of some type of some dimensions. Wait a minute. See, when I am writing, you are also reading it. Don't write. Read it. Okay? So that you understand it and then you solve it. Data type is also not given. All three dimensions are not given. For calculating the address of any location A of I, J, K, the steps that are taken by the compiler, because it will generate machine instructions. So we are not showing machine instruction. It is just preparing separate instructions. So what are the instructions prepared is T0 is 1024 into I. T1 is 32 into J. And T2 is 4 into K. And T3 is T0 plus T1 plus T0. T4 is T3 plus T2. See, if you observe, in every step there is only one operation performed. That's how when it is writing machine instruction, for every instruction only one operation will be there. Multiple are not there. So I am not writing machine instruction. I am writing simple syntax, mathematical syntax. Then T5 is X of T4. Means whatever the address is obtained. Understood? So compiler is performing these steps, multiplying I with 1024, J with 32 and K with 4, then adding T0, T1 and getting in T3, and adding T3 with the T2 and getting in T4, and now finally it has the address. X of that address is what? It's getting the value in T5. For finding the data or address of any location A of I, comma J, comma K. This is how it is computing. And this is a three-dimensional array. Alright, so we don't know what the data type is, what the dimensions are, and your job is to find out data type, and dimensions. So don't answer, don't answer. You have to find out data type and dimensions. So for making it easy for you, I have brought the formula also here. This is a row major formula. Take your time. It's a simple one only, not difficult one. You can answer it. It uses that formula. That formula is broken into steps. In this question, options are given. So when options are given means question becomes very easy. It becomes very easy. I am not giving option, so it's a little difficult. The same formula it is processing here. It's processing the same formula. So that's why it is having I, J, K and plus plus multiplication. Plus plus is also there, addition is there, multiplication is there. All those are done in every separate steps. Same formula it is taking. आया आंसर आ गया? क्यों? सिंपल क्वेश्चन है वो. See, I said that this is using row measure formula for 3D. And also I have given you row measure formula for 3D. That is L0 plus I into M into N plus J into N plus K whole multiplied by W. Let us open this one. So I into M into N into W. Open this. Plus J into N into W. Plus K into W. This is the formula. Multiplication plus multiplication plus multiplication plus L0. Multiplication, 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 those two plus here, then L0. Same formula is there. It's not done at once, it is done in step. So if you see, is there anything getting multiplied by K? If you put it in the bracket, you don't realize nothing is getting multiplied, then how come K is having something multiplied? If you open the bracket, then K into W. So what is 4 here? What is 4 here? W. So this is nothing but K into W is 4 into K, right? So 4 into K. So it means W is nothing but what? 4. So you know the value of W now. W is 4. W is 4. Now if you see this J into N into W, J into N into W is what? 32J हुआ ना, 32J लिखा हुआ है, 32 into J. So W you know already, how much it is? 4, 32J. अगर ये 4 उधर भेजेंगे तो कितना हो गया? 8. So what is the value of N now? 8. So N हो गया 8. Now same way, I into M into N into W, this part is 1024 into I. 1024 into I. Right. So this N into W is already, you know, that is 32. So this is 32. And if you send this on this side, 32, divide 32 into 32 is 1024. So what is M? M is 32. NW 32 है ना ये, यहाँ था ना ये NW. NW was 32. So 32, if I send it on that side, 32 into 32 is 1024. So M is how much? 32. हो गया? कुछ डाउट है? हाँ. Now, L we don't know. M is 32. N is 8. And data size is 4. 4. It may be integer or it may be float. Alright. One of the dimension you cannot know. One of the dimension you cannot know. Because that is not there in the formula. Now, this is 8, this is 32, and this data size is also perfect. Then whatever is written here is okay. If I am writing 7 also it's okay, 9 also is okay, 100 also it's okay. Anything is there, okay. So now, see, it has taken time for you to reach the answer because options were not given. And most of the time, options I will not be giving. So you will spend some time and understanding and solving the question. If options are given means you will directly go there. This is the answer. This could be the answer. You can easily go there. It will not take this much time. No doubt you will not give it quickly also. So only what was there here, see in this entire question, what he was testing? Opening the bracket. Opening the bracket. Simple thing he was checking. Can you observe that opening the bracket or not? If once you open it, everything is clear. Understood? So that's what. So the questions are designed in this way. So this is the trick behind that question. You realize you are thinking that K के साथ क्या multiply होगा? कुछ नहीं होगा, यहाँ 4 क्या लिखा हुआ है? You are not opening the bracket. If you open the bracket, then everything is clear. That's it. So we'll stop here. Next is we have to see the operations. This is over row measure, column measure. I have shown you 3 GATE questions on this one. 3 GATE questions were there. All right. One was the comparison, multiplication type, and 2 addresses I have given. This was one of the difficult one. Though it is simplest, but it was difficult to realize and understand the question also. Just little difficult. No doubt the formula was there in front of you, still it was difficult. Without formula, it's little difficult to realize what is happening actually in the question. So tomorrow we'll see the operations on an array, various operations like insert, delete, search, binary search, linear search, reverse, time complexities. These are the things that we'll discuss. So any question from online students? Yes, Sudhir has given the correct answer. Yes, correct. Very good. And Vamsi also has given the correct answer. That's great. 59. 1. Okay, 9 minutes back you have given. Correct. Okay, we'll end our session here, stop our session here.